In this video, we're going to prove the fourth and fifth rule of our list, and that is the product rule and the quotient rule. So let's start with the product rule. And before we do that, let's look at some examples. So let's go over here, and this is how I think of it. You can think of it like this if you want to. This is the product rule. First thing you do is you just repeat the two functions that we're dealing with, put a plus between them, and then you repeat them again. And of course that doesn't make any sense. So what you have to do to get the product rule is differentiate that one, the f, and then over here differentiate the other one. And we see the 1 there. So that is correct. All right, let's look at a couple more just to cement that idea. So the way I do it is I just write them down first of all. So this is the sine of x times the cosine of x plus the sine of x times the cosine of x. Then you have to differentiate one of the terms, or one of the what would you call them, one of the things in the product, and not the other. So this one we're going to differentiate that, and the formula or the formatting for that is this here. All right, so that's derivative of the sine, and then you go over here and you differentiate the other one. That's the derivative of that. So really, just if you're doing this with pen and paper, you just prime one and prime the other. I have to use a certain formatting symbols so the program recognizes what's going on. And we see that we have a 1 there, so that is valid. And what about this one, last one for the product rule? Again, you just take the two functions and you repeat them. Well, in this case, I'm not going to do that. I'm going to combine those steps. So the derivative of the first one is going to be 2 times x plus 1. And now I multiply that times 3 times x cubed minus 5. So I'm just repeating that one. And then I put a plus down, and I type in the first one, no changes, minus 1. Then I differentiate the second one. That's going to be 9. Got to put it in parentheses. 9 times x squared, and that's it. And I get my 1 there. So that's true. All right, and now let's go look at the quotient rule. And notice its similarities. It's similar in many ways to the product rule, and this is the way I think of it. You say, all right, let's just repeat what we have there. So that's f of x times g of x plus f of x times g of x. Then you say, well, wait a minute, that's the product rule. I got to make two changes. Well, actually, before you even do that, I have to, this is not quite the product rule yet. I got to differentiate the first one, differentiate the last one. And if I hit enter, notice that we're not there yet. This is not a 1 down here. So we have to remember, you have to make two changes to your product rule formula. And one of the changes is divide by g of x squared. So that's the denominator back here. It's f of x over g of x. So we divide by that g of x, and we turn this into a minus. And we have the 1. All right, here's one final example for the quotient rule. Well, how is this a quotient? I don't see a quotient there. But remember the definition of tan. That's the derivative of the sine of x divided by the cosine of x with respect to x. So those are the same formulas. Tan of x is sine over the cosine. Now it's a quotient rule. So I'm going to, first of all, just write down sine of x times the cosine of x plus the sine of x times the cosine of x. And I know that's not right. I have to make two changes to that. And let's put parentheses around it. We need parentheses. So the first thing I'm going to do is divide by the denominator. So that's cosine of x squared. And then I have to put a minus here. And notice I don't have equality. What have I not done? What did I forget to do? Well, you got to also differentiate these things. So the sine of x is the derivative of the sine of x is the cosine of x. And the derivative of the cosine of x, we've just proven that in the last module, is minus the sine of x. That means this minus here is going to have to become a plus. And we get our 1. And this can be simplified. Let me see if I can simplify it. We may need a trigonometric identity here that I haven't gone through yet. But yeah, let's wait on that. We're missing one trigonometric identity, but we can simplify this thing a little further. All right, well, let's get to the proof of the product rule and then the quotient rule. So let's go to this figure here, and what we're going to do is start with the definition, or what does this mean? And that should be one of our conditional ops. This is the definition of that thing. Notice we're just taking f times g at x plus h. That's what this first thing is. And we're subtracting from it f times g evaluated at x. And now here's the trick that we saw a short time ago. And as I said, this comes up in a bunch of places. You add and subtract, or really subtract and add the same thing, and you mix it up. You look at that first piece and you say, all right, I'm going to stick in an f of h plus x from the first piece, but then I'm going to multiply that times a gx in the second term here. I'm getting my gx from over here. But of course, that changes everything. So I have to copy that and add it back in. And now that should be the same as what I started with. And let's see. Yeah, here it is. Here's what I started with. This is my derivative right here. This is the evaluated at a particular x, and I still have that, so I haven't made any mistakes yet, or at least no obvious ones. All right, so let's go on. The next thing we do is group. We take well, actually we got to do a little rearranging first, right? We want to take the what is it? No, that's it. We want to group the first two together, just as we have them there. We group these two together and the second two together. Okay, so now we have a sum over h, and let me just put that in slightly different form so maybe it's a little clearer. Let's put it in the a over b form. So we have the sum of two terms divided by h, so I can split that up and distribute that h and divide each term separately. So let's see if that's one of our conditional ops. It should be in there. Hang on a second. Here it is. A plus b over c is the same as a over c plus b over c. See if it works. Okay, so that split it up. And now look at the terms. My little groupers, I don't need those anymore, so let's get rid of my grouping. And let's do what? Well, look at this one here. It has an f of h plus x in it and an f of h plus x. So if I factor all terms, that'll come out. And over here, this has a g of x and a g of x. So if I factor all terms, that'll come out. Right, now we're beginning to see something that looks familiar. I see here g of x plus h, or same thing, h plus x, divided by h. Well, that's the derivative of g. And over here I see f of x plus h minus f of x, and divided by h, that's the derivative of f. So let's see how we can get there with being a little more careful about things. What I want to do is just split these quotients up in a certain way. So let's see if we can do that. Okay, we want to factor out terms in each one. So do I want to factor that one out of the first one? No, I want to leave that one in the quotient. But that one I want out. And that one I want to leave in. And what about this one? I'm now working over here. I'm factoring things out of that a over b form, and I want to leave that one in, but that one comes out, and that one stays in. Okay, so now we let h go to 0. So what does this one go to? Well, as h goes to 0, we're assuming f is continuous. This one just goes to f of x. And what about this thing here? That goes to g prime of x. And let's see if that's one of our substitutions. There it is. That's g prime of x. And what about this f minus f over h? That is f prime of x. So let's make that substitution. And there we have it. That's the formula that we wanted to end up with. So that's the product rule. Let's go on and do the quotient rule. There are two ways to do it. We're going to do it using the chain rule. This is another reason the chain rule is so useful. So let's look at this picture here. Let's define the function h of x to be 1 over g of x, where g of x is our function in the denominator. We know how to differentiate that. Now that's the chain rule right there. This is g of x to the minus 1, and I think we saw enough of those in our previous module to know that the derivative is this thing here. The derivative of h is g prime of x divided by g of x squared. So we're going to use those two facts to calculate the derivative of the quotient. And here's what we're going to do. I want to see this as a product rule, so that's why I define h of x as 1 over g of x. I make that substitution. It didn't do anything. Let's see if we have our substitutions here. No, we don't. Nope. Okay, let's see if that's on there someplace. Yeah, here it is. G of x is 1 over h of x. I make that substitution. Now I can apply my product rule. So this is, and I'll do it all at once, this is f prime of x times h of x plus f of x times h prime of x. And I've got my 1 there, so I've done things correctly. Now we're going to substitute for h prime of x. H prime of x is this thing here. Substitute that in there. And notice it gets a gx squared on the bottom. So that's, we're heading in the right direction. And I want to eliminate h from my formula. I want to get everything back to g, so I just make this substitution. And now I have g of x squared on the bottom of one term and g of x on the bottom of the other term. This looks like a situation for common denominator. So let's see what that gets us. Common denominator. Yes. And there it is. We're done. Let me put it in A over B style just so you can, it's a little clearer what's going on. Okay, there's our formula. We have f prime g minus f g prime over g x squared. So that is the proof of the quotient rule. Now we could do that in the same way we did the product rule by adding and subtracting a piece, and you might want to try that. You end up at the same place. A little messier because you end up with some, you have to take a common denominator within a common denominator. So it's a little messier, but it can be done without too much trouble. So that's enough for the product rule and the quotient rule.